Okay, we're going to do it again. Because I have a conviction. My conviction is we want to talk about new math. But it's not new math. It's old math. But it's old math with new math. And I don't understand. Okay, anyways. So, what are we going to do? We're going to be counting. So when we count, it's 1, 2, 3, 4, and then 5. 5, 6, 7, 8, and then 9. What we're going to be doing is we're going to be workshopping this. So, welcome, Monica, welcome. What we're going to do is we're going to count on the abacus. So, what's the counting on the abacus? This counting on the abacus is a manipulative, right? It's a math tool. It's a math tool. So, we're going to count 1, 2, 3, 4. Notice that all the beads that are touching the horizontal bar is considered counted. So, if it's considered counted, this is what we're doing. So, we're counting 4 on the abacus, and then we have 5. This is what 5 is. How do I know? Well, all the top bead always has a value of 5. So the top bead always has a value of 5, and it's touching this horizontal bar. This horizontal bar tells me that these beads are being counted. Hey, Brian. So what we're doing is we're counting on the abacus, and the abacus helps me figure out where all the beads are. So what we're going to do is we're going to do counting. 5, 6. So we have 6, 7, 8, and then 9. So we have 9 right here, but then this would be 10. Just as we write 10, 1 and 0, we have 10 on the abacus. So let's count. 1, 2, 3, 4, and then 5. That's 5. This is not 5. This is 9. So this is 9, but this is 5. So we have 5, 6, 7, 8, 9. So I am just checking to see that my microphone is working. Okay, so we have 9, and then this is 10. So when we count, we have 11, 12, 13, 14, and then 15. After 15, we have 16, 17, 18, 19, and then we have 20. How do I know? Because if you look, I have this dot right here. This is my indicator, and this indicator tells me that this is where my ones place is. So we have it where this abacus tells me where the ones place. But I can choose any dot that I want. I could do this one. Oh, this one is not. There we go. So I can either choose this dot or this dot. It doesn't really matter. But if you notice, we actually have our indicators. This is the indicator for our ones. This is why we don't have this. So if this is my ones, this is my tens, this is my hundreds, thousands, and 10,000, anything after that will be my decimals, just like money, just like change. So we could do $10.25. So if I wrote it out, when I write it out, let me write it out. So we have, just like how we do 10, just like how we write 10.25. Whoa, that doesn't look good. There we go. Okay, well, we have that. So just as we have 10, it's the same thing. We have 1, 0, and then 2 and 5. So that's what we do on the abacus. When we write on the when we read the abacus, it looks exactly how we write it. So we have $10.25. So now we have our decimals. Excuse me. So this is 11.25. Excuse me. Okay. I think I'm good. So we have 11. How do I know it's 11? Because there's 1 and 1. Not a good way to start my life when all the allergies come about. Sorry. So we have one bead touching, and we have another bead touching. This is 11. So we have our ones and our tens. We have 12, but we actually have $12.25. So if I wrote it, it would look like this: 12, 1, 2, point. So if you notice, the decimal actually sits between the two place values. So we have 25, and then love learning new things. Hi, Miranda. Thank you. So what we're doing is we're counting on the abacus, and I just had a little bit of a coughing spat. Sorry. So, excuse me. So what we're doing is we're counting on the abacus. Counting on the abacus just means we're going to learn how to read the abacus. After we learn how to read the abacus, we can do adding, subtraction, multiplication, and division. And there's a little thing that I found that this is new water. Hey, Jose! Yes, I'm drinking more water. Oh my God, I got like a whole bottle of water. This is crazy. Anyways, thank you. But you know what? You know what? The reason why I'm on is because I have this conviction that new math is actually abacus. When I saw it, I'm like, oh my God, they're teaching abacus, but not with an abacus. And I'm like, why are they not using the abacus? So before we go all of this, we got to know how to count. Before we know how to add and subtract, before we know how to do division and new math with the abacus, we need to learn how to count. So we're going to count on the abacus, and that's the easiest thing to do, right? Simple to use, easy to understand. The first thing we're going to do is we're going to count 1, 2, 3, 4. How do I know? Because all the beads, 52 people in the live. Wow, that's fantastic. So thank you for letting me know. So we have 4 on, and this is touching the horizontal bar. They're all watching me cough. Sorry. So this is all touching the horizontal bar. When the beads are touching the horizontal bar, that means that they're counted. So we have 4. Easy, right? Just like how the die. Just like how we have a die. Sorry. We have a die. This is 6. No, this is 4. So just like how we have a die, this is 4, this is 4. So on the abacus I have 4, on my die I have 4. Not a problem. Oh yeah, not a problem. But this is more selfish because I gotta workshop the whole new math thing, because we're gonna start learning new math with an abacus. I will bet you this. I will bet you this. So after 4, what do we have after 4? We have 5. But we don't have enough beads for 5. We do have enough beads for 5. The top bead will always be 5 no matter what. Thank you for the share, Jose. So I'm actually quite excited about kind of workshopping this idea of new math. Anyways, so the first thing we need to do is we need to understand how to read the abacus. We have 5. This is always going to be the value of 5. So if you notice my columns, all of these columns is all 0 except for this one. Now, why did I choose this one? Because I have an indicator. This indicator is my ones place. When I have my ones place, I know this will be my tens. Oh, yeah, shared it with my girlfriend. Nice, Jose. Okay, I hope she enjoys abacus like we all do, because we like to midnight math. All right, so we have 5, we have 6, we have 7, we have 8, and we have 9. So this is 9. We know that this is 9. All the beads, when all the beads are squished together like this is 9. So when we look, this is 9, and then this is 9, and then this is 9, and then this is 9. Am I going too fast? Let me know if I'm going too fast. I can slow it down. But I'm so excited about this. I'm so excited because new math is actually abacus. And I will, yeah, it's crazy. Okay. So what are we doing? We're counting. This is 2. This is 4. This is 9. Make sense? Oh, hey, Kai. I'm loving this too. Welcome, welcome, welcome. Welcome, everybody. Thank you so much. Hey, delete. Okay, so we have 9. So we have 9. And then we have 90 because it's a 90. And then we have a 900. You're absolutely right, delete. That's an interesting username. I saw another username that says pour milk before cereal. And I was like, what? Anyways. But yes, exactly, delete. That's what it is. So then we have the 9,000, right? So this would be 9,000. So we know our place value. Easy, right? Simple to use, easy to understand. Simple to use, easy to understand. Abacus helps us do the place value. Make sense? Easy, not a problem. So let me know if we have any problems, any questions. I will go back and I will do a little refresh. But we understand. We have 1, 2, 3, 4, and then 5. All the top bead will always be a value of 5, no matter what. That's just the way it goes. So just as delete said, instead of doing 9, we could do 5. This is 5, this is 50, this is 500, this is 5,000, and then this is 50,000. So 50000. So if you notice, I have these indicators. These indicators tell me that we're sectioning off. So we have our ones, and then this will be our thousands. Just like, why are you staring in the middle? Oh, starting. I'm staring in the middle. I'm staring in the middle of the camera. I'm starting in the middle because of my ones place. Yeah. So what's going to happen? Hey, you're going to be watching the lunar eclipse tonight? I guess we will be after my live, right? That's what it is, right? So, okay. So, Indy 101, the reason why I'm starting over here, because I have the indicator. This indicator tells me that I'm going to use my ones place by this dot. You could go here, but then it gets confusing when you get more numbers and it'll be like, oh my God, I don't remember where I started. So the indicator helps me label where my ones place is. And I'm just playing around with but yeah, Bree, I am going to go watch the lunar eclipse after after this live, because I'm quite excited. I'm really excited because I was doing some research on what new math is, and I'm like, what's the value of each color? Hey, the value of each color? Actually, it's not the value of each color. The color doesn't really matter. It's halfway. Ooh, okay. I'll have to take a break and then go watch. Okay. Oh, I don't know if I have time because it depends on how many people. Okay, sorry. So the color is not necessarily the issue. It's the placement of the abacus. So the top bead is a value of 5. The bottom beads of this horizontal bar is a value of 1. So when we look, this is 4. How do I know? 1, 2, 3, 4, and it's in contact with the horizontal bar. It's touching this horizontal bar. This horizontal bar will tell me that, oh, thank you for the heart puff and the rose. The horizontal bar tells me that this is what's being counted. So we have 4, and then this will be 5. So make sense? So when we count it, we have 6, 7, 8, and then 9. Ooh, halfway. I don't know if I could see it. Is it cloudy? Yeah, makes sense, right? So just like, okay, so this is the colorful one, but then there's this one. So now it makes more sense because this works exactly the same. Because it works exactly the same, what we're talking about is the positioning of the beads. So we call this the top bead. The top bead is 5. All the top beads will always be 5, and we can count it just like all the others. 5, 6, 7, 8, and 9. That's it. Bam! Mic drop. Or lunar eclipse. Yeah. I can't see the lunar eclipse from my room, but that's okay. That's okay. I'm actually, thank you for the heart meat and the lightning bolt and the corn. Wow, we're getting kind of full here. Okay, so I slept and you were alive. I woke up, you're still alive. I love the enthusiasm. That's funny. I'm so excited about this. I'm so excited about this because I think I figured out. I think I figured out why everybody was griping about new math, and I realized new math is actually abacus math. I don't know if you guys know, but you guys have like people who are learning the new math is actually learning abacus math. But I'm just saying, it's just still not structured. When do you think we should start using the bigger abacus, like the bigger ones that we're not? Well, it depends on how big your numbers are. So I would probably use, if it's for you, I would start it right away. If it's for a child, I could probably go maybe 5 years old to this. The reason why is because the numbers of the question doesn't get bigger until they get older. So for you, Bree, I would probably start with the 13 column anyways, because you're gonna quickly go into the bigger numbers, and so you going with the bigger numbers, it will be fine. So V54. So we go. Okay, you know what? 54. We do 54. What's 54? 54. 50 and the 4. That's how we do it, right? Woo! So yeah, it's really interesting because I was just looking, TikTok always, just kind of looking at things, right? And I'm trying to do research on how mainstream math does it and how does Abacus do it. And one of them, okay, you know what? I'm just gonna workshop it. Okay, we're just gonna go. How was dinner? Dinner was fantastic. Dinner was fantastic. Thank you for asking. Oh, but and then I sat down with my kid and we did some homework, and oh, it was a lot of homework. But it was good. It was good. And then I was doing more research, and I was doing research. Can we do the? No, you know what, Megan? You know what we're gonna do, Megan the pagan. We are gonna do this. This is what I found. I found new math, and I'm like, I can do new math. I will show you how we do new math, but in the abacus way. So let's do it. Let's do our times table. So we'll do the 3 digits times 2 digits, and then in the next picture, in the next one, what we're gonna do is we're gonna do the 2 digits by 1 digit. So one of the new maths, I'm gonna do this. I'm gonna do this. So in Abacus, we need to figure out, okay, I'm getting to the point where, okay, everybody understands how to read. Not a problem. If you don't understand how to read, we'll go back. But what we're going to do is we're going to start going into how to do multiplication. Now, we do multiplication. What we need to do in Abacus is we need to find where we're going to put our answer. When we put our answer, we're going to put it here. The reason why we're going to put it on the third column is because I have 3 digits in my question. That makes sense? We're good? We're good? We're tracking? We're okay? Okay. So, notice when I do this, I will do 4 times 9. That's the new math. And I'm like, this is funny. This is so funny. So I was looking at it, and what they do is they break up this 97. It's exactly what Abacus does. And what we're doing here is we're actually doing distributive properties. Distributive property. So what we're going to do is we're going to take the 4 times it by the 9. And then new math is so much better in my opinion. New math is actually Abacus math. And Abacus is not new math. Better not than Abacus, better, wait, I'm sorry. Not better than Abacus, better than algorithm. Oh, yeah. Yeah. So what we're going to do is we're going to do 4 times 9. But the way they broke it up is because in new math, they're writing it out. But in Abacus, we don't need to write it out because we have the Abacus to keep track for us. So when we do it, we are going to do 4 times 9 is equal to 34. So we don't say 90 times 4. We don't need to track that it's 90. We just need to track that it's 9 times 4. So 9 times 4 is 36. So notice when I do the Abacus, it already tracks it for me. I add the 30 and I add the 6. And I move my finger because I want to keep track of where I'm going, what I'm doing. Does that make sense? I mean, this is new math, but this is not new math. This is Abacus math. I'm so cool. This is so exciting for me because this is not new math. What I'm doing, so the only thing I have the problem is everybody doesn't understand how to read an Abacus. But once you understand how to read an Abacus, everything is golden, right? So here, my next one, I'm going to do 4 times 7. On the Abacus, I do 4 times 7. 4 times 7 is 28. I guess, right? I can't wait to show my son, right? But that's what I'm saying. I'm going to add 20. I'm going to add 8. That's it. This is new math. So what do they do? Then they write it out. They write it out, 360 plus 228, and then they write it out. But because I did it on my Abacus, I don't have to write it out. I have to figure out how to workshop this. I got to figure out how to create a video on this because it blows my mind. But then the problem is people get hung up on is I don't know what I'm reading. So if we look at it, we have 3. This is 3. We have 8, 5, 6, 7, 8, and then another 8, 5, 6, 7, 8. What am I trying to say? In Abacus, we don't talk about the tens. We don't talk about the zeros because on the Abacus, we already do it. I'm so excited. I just got to figure out how to compare. Could you show an example of doing subtraction sum with Abacus? Yeah. So we can do this. Let's start with the simple ones. So in Abacus, in learning how to add and subtract, there are specific framework that we have to talk about. But before we start doing that, we need to understand how to read the Abacus and how to move the beads. So when we do it, thank you, Kai, for the question. When we do it, we do 6. We have 6. So on this question right here, we have 6. And then all I need to do is add the 2. So I'm going to add 2 beads. That's it. The question is do I have enough to add 2 beads? Yes, I have enough to add 2 beads. So I'm going to clear my Abacus and I'll do another one. So we can do this one. We can do 2. So we have 2 plus 2. Again, I'm starting in the middle, kind of in the middle. But where it is, I'm starting where my indicator is. My indicator tells me that this is my ones place. So this is why I start over here. I could start over here, but then I confuse a lot of people because I know I jump around and people are like, wait a minute, you said this. And I'm like, oh, okay. But, so let's do another one. So we have this one here. And I'm going to start with 7. So when I have 7, this is 7. 5, 6, 7. And then I have 2. I want to add the 2. So notice, hi, Melinda. I just went through new math. We can talk about it. It was like fantastic. New math is actually abacus math. But yeah. So, okay. So basically you have to use all 9 before you go to the next column. Exactly. Exactly. Yes. So what's going to happen is this is 9. So if I want to go to the next one over, which is 10, I would have to do a formula. And that one of the formulas is understanding how to make a 10. But the first thing we need to do is understand how to make a 5. Oh my gosh, your excitement is infectious. I'm so excited. No, you don't understand. I appreciate that. Thank you, Rachel. So, yeah, and it helps when other people like from my previous lives come in, like Bree and Melinda, and I'm like, oh my god, I've got new math, which happens to be abacus. Okay, so Kai, does it make sense? We're just moving the beats. When we move the beats, notice we're focused. Actually, we're focused on the add-ins. We're not focused on the result. We're teaching everyone today. Oh yeah. I'm like just getting ready for work and I had to stop and watch. Yeah. So, so one thing about abacus is we don't focus on the result. We don't say, "Oh, this is 8," right? Okay, 6 plus 2 is 8. Yeah, we don't say that. What we do is it's plus 2. Yeah, that's what we do. We say, "Okay, how do we add the 2? Is there enough to add the 2?" So what I'm going to do is I'm going to add the 2. That's it. That's it. Right? Kim, you're here. So when we add the 2, we need to focus on the add-in. Why? Because that's what's going to leverage on the other things that we're going to do when we do more adding. Okay, so the next one we're going to do is the 3. Well, let's do 4. The 4 doesn't have a lot of questions because, there's only so many questions you can add 4. So here I have 5. So I'm going to add the 5 and then I have 4. I have 4. Do I have enough? Yeah, I have enough. Now it gets to the problem where what happens if I don't have enough? Thank you for the follow. I feel like it'd be great skill for my daughter. She's in preschool. Yeah, that's not early at all. You know why? Because I created a book for preschoolers. The reason why is because in Abacus, we started the kids in when they were 5 and they already know how to number and all this and that. And I'm like, no, 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 no. We need to start them earlier. So I made something. I made this workbook and it's available on Amazon and you can find it with my name. My name. That's my name. But no, I started a student. And my student was 3 years old. I have had him for he's 4 now, so I had him for a year. And the biggest thing is just we go through counting and understanding, and we do correlations. So this is about trying to make sure understanding what the beads are, what the number is, and what the items are. So and it's just like trying to figure out like the relationships. So there's 12 lessons. First lesson is 1 to 4. Second lesson is 5 to 9. And I only stayed with the one column because I didn't want to talk about place value. And then after that, it goes into relationships, like how do you count forward, how do you count backwards, what comes in between, and so forth. And then towards the end, about lesson 9, lesson 10, lesson 11, lesson 12, that's when we start doing the adding. But we're not doing adding with the formulas, because what the kids should be doing is they should be understanding how to move the beads. So here is my 7, so I'm going to add the 7, I'm going to add the 1. So it would take some time. Making this book is perfect for my kids. Oh yeah, hey Indy, welcome. That's great. That's great. I'm excited. I'm really excited that this is working out. Like, yeah. Anyways, I'm just super excited with the new math. But yeah, I made, and I also have a plethora of worksheets. I just haven't condensed them all into a workbook. But I feel like the workbook is better because if there's too many papers, it's a lot of papers that fly around because kids go through a lot of paper. I'm not gonna lie. So I was going to make another book. I'm still working on my other books. I have 6 books in Amazon right now, but they go into sequence. So after this would be the plus 5, which is what we're going to talk about. Which we're going to talk about. Why? Because we need to start understanding how to make a 5. This is not it. It is this one. So after we make a 5, I need to find my book. We're going to be making a 5. Where's my book? It's not here. Oh, here it is. It's all buried away. So after the preschool one, we're going to be making a 5. After making a 5, hey, chef, welcome. I know you've been around. So I love this. I was born in Ecuador and was taught with math with an abacus. Oh, but I had 10 rows per bee. Okay, the 10 beads per row, I don't know, has formulas. But in the soroban, which is the Japanese abacus, we use formulas. And so one of the formulas we need to understand is how to make a 5. In school, in regular school, we're teaching the children how to make a 5. But in abacus, we're going to take it a step, we're going to take it up a notch. And that would be how to utilize it. We're going to make this work. So what does that mean? So the first thing we're going to do is we're going to understand that if I show you this 2 and I want to add 4, you'll notice I don't have enough beads. So this is where a formula comes into play. The formula we will see is going to be plus the 4 is equal to plus the 5 minus 1. This is not filled out. It's empty because this is a workbook and I wanted the kids to write down that this is supposed to be 1, like that. So why are we doing this? Because they need to memorize this. Yes, we learned it in second grade, but 10 beads to learn to count basic addition, subtraction. That's very interesting, Kimura. But you know, on this abacus, and I know I've seen on YouTube that you can actually do multiplication and division on that sort of abacus, but I don't know it. I only know how to do it on the soroban, which is just the Japanese abacus. And I truly believe that abacus is the greatest thing next to sliced bread. And somebody, was it Kim? Somebody said that Betty White was before in sliced bread. So, but yeah, okay, sorry. So second grade, that's really interesting. And like, yeah, this one actually can carry all the way to, so my child right now is in 6th grade and he's had some little bit like, you know, they go through questions and stuff, and I have them like figure it out on the abacus because it's just easy. Not me. Oh, not okay. Not no. There was another Kim. There was another Kim, like Kim Sunshine or something. And she was in earlier. Oh, so why are we learning this? The reason why we're learning this is because we don't have enough beads to add the 4. When we do not have enough beads, we have to start utilizing this thing called formulas. So let's start talking about the foundation of a formula. So when we talk about the formula, what does that mean? Just as we talked about how to make a 5. So when we make a 5, please put in the chat what are 2 numbers to use to make a 5? But I want to add a 5. Let's do adding 5. So my first one would be 0 plus 5 is equal to 5. So in the chat, can you put in what other ways to make a 5? Why are we making a 5? Thank you, Melinda. 4 plus 1 is equal to 5. And then 1 plus 4 is equal to 5. And then the other one, right? You have another one, which is 2 plus 3 is equal to 5. And then 3 plus 2 is equal to 5. Thank you, E8. Thank you, 8, Aaron. Yes, thank you, Melinda. So why do we do this? Well, in school, this is what we teach, right? This is all we are teaching. But in abacus, we actually take it one step forward. We can take it a step notch. Why? Because we don't have enough beads to add a 4. Or we don't have enough beads to add a 1. So let's look. So we have 1, and then we're like, wow, now what? Well, what's going to happen is we need to isolate the variable. The question is, we're going to start simple. The question is 1 plus 4. So I have the 1, but I don't have a 4, right? I only have 3 beads. So because I only have 3 beads, I have to figure out what is my next step. My next step is to figure out how to add this 5. I can utilize this 5. I can make it work for me because it cannot be a slacker. No slacking on abacus. Every number gets used. What does that mean? Well, let's isolate the variable. We're going to isolate the variable. we're going to isolate this variable. This variable is the same, right? We're going to isolate that variable. To isolate this variable, we're going to move this 1 to the other side of the equation. When we move it, I'm going to rewrite the formula. It's plus 4 is equal to plus 5 minus 1. So I took everything that's in here. And I rearranged it. I'm becoming more number flexible. Those are all the terminologies that we're all using, right? We want to be number fluent. We want to be number flexible. So this is how we add it. What we do now is, okay, what am I going to do? All I need to do is add the 5 and then minus the 1. So I'm going to add the 5 and minus the 1. And you're like, wait a minute. So the answer is 5. That's a lot of saying right there. Why do we need to do it when we just know 1 plus 4? We know it. Well, it gets better. Let's do another one. Let's do 3 plus 4. Again, we have the same thing. What's the same thing? The same thing is this add-in. This is the add-in that we're focused on. We want to focus the add-in. We want to focus the number that we're adding. When we know the number that we're adding, we're able to utilize it. We're able to figure out and become number fluent, math fluent, all the other fancy terms that they talk about, numeracy, and all this and that. What does that mean? Well, this 4, excuse me, I have 3. Notice I don't have enough beads to add the 3. This is a concrete idea. This is a concrete thing, right? We could see I don't have enough beads to add the 4. So where am I going to grab it? I can grab it from thin air. No, you can't. We got to be logical about it. To be logical about it, we're going to utilize what we already know. We know how to add a 4. All we need to do is add the 5 and take away the 1. So my answer is 7. Make sense? So what we're trying to do is we're trying to understand we're going to focus on the add-in, right? That makes sense, right? Yeah, right? Oh, I think I kind of understand. Yeah. So 8, Aaron, before I continue on, we're going to count. When we count, we have 1, 2, 3, 4. Hey, Princess Pinup. We have 4 and then 5. This is 5. We know the beads touching the horizontal bar is counted. When it's counted, this is 5. This is 6, 7, 8, and 9. So after 9, this is the ones column. This will be 10. So why am I here? Because I have my indicator. This indicator is my ones place. On my ones place, I know that this is the ones. This will always be the tens. That's how we write it, right? When we write our numbers, we have 10. So we have 10, 1, and 0. Here is my decimal place. I have 25, like as if we were talking about money. So the blue represents 5. Like tally marks, you know what? Exactly, like tally marks. We do 1, 2, 3, 4, and then 5. So we have 5, but the difference between the tally marks and the abacus, on the abacus, we cannot break up the tally marks. So we have 5. Let me do 5, right? We have 5, and then when I want to do 1, that's 6. So this is 6. Exactly. Actually, this helps me understand a bit since I'm currently in college. Oh, I'm trying to be a teacher. Oh, fantastic. Oh, fantastic. I will teach you new math with an abacus, which is old math. I'm telling you. Where did that come from? It was a comedian. I'm telling you. Oh, I forget. Oh, I love comedians. Anyways, so, right? Okay, so this is how we're counting on the abacus. We need to understand how to read the abacus. When we understand how to read the abacus, we can go further on. So I used to have an abacus when I was a bit younger, but it's gone. Well, I wonder, 8, Aaron, if your abacus was a soroban, or was it a Chinese abacus, or if it was a 10 bead. So Kimura said that Kimura said that they had a 10 bead, and 10 bead is different than a soroban, because in the soroban, this is a soroban, this is a Japanese abacus. We actually utilize formulas. One of the formulas is this one. This is making of a 5. So in school, we teach the children how to make a 5. Not a problem. In Abacus, we utilize it. We actually make the numbers work for us so we can see what we're trying to do. This is what we're adding is the number fluency. We're adding in number sense. We're adding in all of that great big math terminology that we're trying to do. So let's take it one step further, right? We've done the 1 plus 4. But notice we only focus in on the add-in. We don't focus on the result. In school, I know we focus on the result. It was a 10 bead, but this reminds me of the various numbers in Roman, Mayan, and other maths as well. Okay, cool. I don't know Mayan math. Oh, wow, I'm at 3,000, almost 3,000 Ks. Hey, Dandelion! Dandelion, you're here! I just had an epiphany. Thank you so much for the heart me. Thank you so much for the heart puff. Oh my gosh, you guys are so gracious. Dandelion, I was just thinking about an epiphany of, hey, Jay! I just discovered what new math is, and new math is abacus, and I'm like super excited. And I was like, I'm going to workshop this out because I need to figure out like how am I going to present abacus as new math, but abacus is not new. I'm just letting you know. It's been around for like ever. All right. So what are we doing? Let's continue on. Excuse me. So what this means is we're not focused on the result. We don't want to know, everybody's goal, we all want to be happy, right? That's everybody's goal, but it's the journey to get there. So in Abacus, we focus on the journey because it's going to be different. That's why when we say we just don't focus on the result. It just doesn't make sense. What we do focus is the actual building blocks. So adding this 4 is a building block. Adding this 4 is the same building block. Let's go with a different number. Let's do a 3, right? So if I do 4 plus 3, this is the same. No, it's not the same. Why? Because it's the second add-in. It's the add-in that we are looking at. This add-in is different. We look at the abacus, we have 4. When we add 4, there's not enough beads to add the 3. That's very different than adding a 4, right? You can have the 3, but then that's the 4. So notice there's a difference. So let's go back. I have 4. When I want to add the 3, what am I going to do? Well, my abacus, my formula, I'm going to manipulate this. I'm going to rearrange it. I'm going to isolate the variable. I'm going to use an algebraic term to make sense. It's going to isolate the variable and move it over here. I'm going to rearrange it. So now it's going to be plus the 3 is equal to plus the 5 minus 2. So when we plus the 5 minus 2, we're going to use another algebraic term. We're going to substitute this information to here, right? So when we substitute it in, plus the 5 minus the 2. My answer is 7. The answer is the same, but to get there is different. So you want to pay attention to the add-ins. Why? Because in Abacus, we do more than just, hey, sunflower. In Abacus, we do more than just 2 add-ins. In Abacus, we do like 4, 5, 6, 10, 20 add-ins, depending on how serious you want to get. But in regular school, we probably do 2 add-ins, so it's easy to focus on the result. But try not to focus on the result. Focus on the add-in. Focus on the path to get there. Focus on the journey to get to the solution. Does that make sense? Okay? We're okay? Okay. Okay. Anything else? Yeah, right? Easy. Simple to use. Easy to understand. I wrote it out. Simple to use, easy to understand. Abacus is the gateway to complex math. Well, what we just did is the plus 5 we just waxed on. And then we're going to do the wax off. We could do a wax off, which is just taking away. Oh, so that was another thing. Because we know this, the next step is when we add, we need to know how to subtract. When we subtract, we already know our pairs. So when we look at this, I'm going to do the I think it's called the inverse. So I'm going to do the inverse. To do the inverse is minus 3 is equal to minus 5 plus 2. That's it. So we just solidified our concept of how to make a 5. We have our pairs 3 and 2. Because we have this, we're building our understanding and our relationships. So when we build our relationships, it's easy to maneuver around our questions. So let's do this one. We have 7, we do 8. We do 8, take away 4? No, let's do 6. We'll do 6. We do 6, take away 3. We do 6, and then we take away the 3. There's not enough to take away the 3. So what do? This is where we know. We already know how to plus the 5, plus the 3 is equal to plus the 5 minus 2. Well, what's the opposite? What's the inverse? Minus the 3. This is minus the 3. This minus 3 is the same thing as that. And then we're going to substitute this into here. To substitute it in, we're going to minus the 5 and then plus the 2. So my answer is 3. Make sense? So that was the one thing is when you know how to add it, you will understand how to subtract it. All right, we're okay? We're good? Wow. Thank you, everybody. Thank you. There's still a lot of us in the room. We're mathing in the middle of the night. We're midnight math. Okay. So, I get it a bit more. Yeah, right? It's easy. I get it a bit more. Yeah. Yeah, I mean, obviously, when you go through it, I mean, I've been teaching for 20 plus years, so, it's easy for me to go through, but I need to go a little bit slower because sometimes when I talk, I know I talk really fast. So I got to take it a notch down a little bit. Yeah, no problem, Kai. Not a problem. So that is adding the 5. Well, what's after adding the 5? Adding the 5, we have to add the 10. So adding the 10, what do they say? Old math talks about carrying on and borrowing. New math talks about regrouping and... Did I see the solar eclipse? No, I didn't see it. I've been here. Can I do long division next? Yeah, I could do long division if we're ready for that. This is helping me for my fundamental math and trying to take the steps to explain. Yeah. Melinda, is the lunar eclipse already done? Is it done? Hold on. Let me go check something. No. I don't see it. I don't see it in my room. No, it's still going. Oh, okay. Oh, nuts. I don't know if I kind of want to do this a little bit more, but it's okay. There'll be another one. Okay. This is helping me for my fundamental math and trying to take the steps to explain. Yeah. So fundamental math, let me know. This is basic. So when you're talking about fundamental math, there's a theory that they talk about the concrete. So this is concrete. Then there's the pictorial, which is doing the bars and the graphs, right? So there's the boxes. This is 100, and then this is tens, and then there's the dots. So that would be the pictorial. And then after the pictorial is the symbol. So you're going to, when you do it, it's fine to do a pictorial, but in my experience, I noticed doing the concrete really helps a lot. Like having it concrete, and because this is easy to manage as opposed to the number blocks. So we have the number blocks, but the problem is classroom management, and it gets really, and then kids can throw these away and they can like toss it around, and then you gotta like clean it up. Whereas the only thing the problem with this is they might use this as a skateboard. Right? So that's the one thing that I was talking to like some other people about, and they were talking about how classroom management with the blocks is very difficult because then you got to take the time to clean it up. Whereas the abacus, it's just all in one, and it's just easier. So it's interesting to see if you can actually incorporate it, but I think it'll be easier to incorporate the abacus because it's now going into more math like this. Yeah, that's my professor was mentioning, which is why we try to move really quick with pictorial. I Yeah, that's the funny thing about it. I think the problem is we push the kids to really we push the kids too quickly to go to pictorial and to go to symbolic, which is the numbers, before they're ready to understand what the concrete is. So even when there's the abacus with the 10 beads, I still think is a better understanding because they can see the numbers. I mean, even like my child, he's 11 now. He's 11 now, and sometimes he gets a little mixed up with the numbers. So what I do is I tell him to take out his abacus and we start working it out. And he's doing multiplication decimals, and he does the fraction stuff, and he gets confused a little bit. But when we do it on the abacus, it works itself out. So I don't know. I mean, it's up to you, but I would this the abacus travels. It can travel all the way to fifth grade, sixth grade. Obviously it's only arithmetic. It doesn't do geometry. It doesn't do calculus, and it doesn't do algebra. But doing like the simple arithmetic, this can carry on, which is really cool. But yeah, the pictorial one still is a little bit much for me, just because it's a lot to see. Just like having these ones, it's a lot. I mean, it's three right now, but when you get more, let's say you get 400 of these, right? 400 is a lot. Whereas if I said 400 here, and I want to add, I want to add 300. So all I got to do, because Abacus keeps track of my place value, so I can easily do translation. If I want to do 300 plus 400, so 300, right? And then what happens is the abacus keeps track for me. So I do 400, and all I got to do is I just need to focus on the one number. And this one number is 3. Do I have enough to add the 3? I don't have enough to add the 3. So what do? I remember plus 3 is equal to plus 5 minus 2. So I'm going to plus the 5 and I take away the 2, which is different. Why? Because I'm not going to say plus 300 minus plus 500 minus 200. That then it gets more complicated, but I don't need to say this because it's already being kept on the abacus, if that makes sense. So abacus makes the make abacus puts math, adding, subtracting, multiplication, division, into manageable chunks. So because it's in manageable chunks, it's easier to understand and move these around. Does that make sense? So it would be great if I knew how to do a research paper, but I don't know. I'm not smart like that. But I do a lot of like understanding like how things work. And I've been teaching abacus for 20 plus years. And so trying to get this to relate to other people, to share it with their children. I live vicariously through my kids. They hated abacus, but they all, everybody doesn't like math. But I do know that going through the abacus, it just helped them understand, and it's also very concrete because they can see it. I recommend having an abacus no matter how old you are, just because it's just easier to see and it's good brain gymnastics. One of the concepts was having, like Sudoku, word searches, crossword puzzles, learning, moving the abacus and understanding the numbers and stuff also helps that as well. So that there was one of a like a it was a thing. Somebody was talking about it, and I was like, oh. So it was one of those things like what it does is it keeps your mind active. And it's not just moving the beads, it's also going through formulas and a framework. There's a formula and a framework for abacus. And I don't have my paper. But there's a formula and a framework. And as you go through the framework, you can see how everything fits. I wonder if plastic or wood beads have a difference in performance. No, there's no difference. There's no difference. It's just newer technology, and the wood one is a little bit more expensive. So I have that one. That's this one. This one is actually made out of bamboo, and it is 23 columns, and it has its own reset counter, but it works exactly the same because the ones that are being used now, the plastic ones, they're being used in competition abacus, and it has to move really quick. So, so the quality of the beads, whether it's plastic or metal, it doesn't matter. So, sound is different. The sound is different. Yes, the sound is different. Yeah, the sound is different, but it works exactly the same. So plastic is for speed. No, no, they're both for speed. They're both for speed. It's just one's more newer than the other. So before, I mean, this abacus is this abacus that's made out of wood is made out of bamboo. This has been around. I've had this for 20 plus years. And then they started mass producing, and then they started doing this. So then they have this. So I was using this one for a while, and then I did this. Sadly, I have to head out for now since it's almost 2 a.m. I'll try to catch you again. Yeah, not a problem. I would listen to you lecture all day. Jay, you're so funny. I will see you again, 8. Let me know when you're ready. I'm live all the time, apparently. Same. Yeah, yeah, yeah. When you get into like doing the math stuff for the kids, it's really quite cool. I really enjoy sharing abacus information to little children and stuff, and I like to see their eyes. So, are we ready? Are we ready for new math? I made notes too, and I was like, oh, I honestly want to do this when I want to become a teacher. Yeah, I need audio description for the place value when you explain it. I just need audio description of the place value when you explain it. I don't know what that means. I fully never learned how to use it. So, Lynette sounds like a teacher reading a kid's book. Ethan. So, Hannah, what we're going to do is we're going to read the abacus. To do that, what we're going to do is we're going to understand that there's the horizontal bar, and the horizontal bar lets us know which beads are being counted. So, as the beads are being counted, they touch the horizontal bar. This one bead that's in the third column has an indicator. Is that what you're saying? While I wash the dishes, mop, and etc. So there's a bead here where it has my indicator, my ones indicator. There's that dot. I was trying to search for the words. That's why I was like a little bit stuck. I'm trying to not use filler words. I'm trying to practice my communication skills. I love Beth. Oh, yeah, I'm a chemist. I'm super interested and never knew how. Yeah. Oh, my God. Abacus is simple to use and easy to understand. Hannah, bottom bead. Yes. So the bottom bead has a value of 1. So 1, 2, 3, 4. We have 4. And then 4 is touching the horizontal bar. The horizontal bar is the key to know what beads are being counted. So as the beads are being counted, we know that this is 4. When we see there's not enough beads for 5, there's no beads for 5, that's where the top bead comes into play. The top bead will always have a value of 5, no matter what. So with the value of 5 at the top bead, we have 6, because what we're going to do is we added the 1 bead on top and 1 bead on bottom, and now we have 6. So we have 5 and 6. So when we squish them together, they're 6. We have 7, 5 and 2, right? Super easy. 5 and 3, 5 and 4. Make sense? So then you might be asking, well, what about my tens? Tens is just like as we write, we have our tens and we have our ones. So when we look at it, Abacus provides our place values. We have our tens, ones, tens, hundreds, thousands, and 10,000. And then after this, right, after the ones, we should know that there will be the tenths and then the hundredths. That is how we have our decimals. And that's it. Hannah, do you have any other questions? But other than that, when we understand how to read it, yeah, the dot is a decimal place. The dot is the indicator of the ones. It is not the decimal place. It is the indicator of the ones, because you can have a dot here or you can use this one. So it doesn't matter, you just choose. It's like Pokemon. I pick you. I pick this one. I'm trying to, okay. Anyways, so why? Because when we look at the 13 column one, there's multiple dots. Oh yeah, there's multiple dots. But notice with the multiple dots, it's the same thing. They group it. You'll notice that it gets grouped. So we have our, if we did this one, it'd be ones. I know this is my thousands. After thousands, I have my millions. Just as we did just as we write in our millions, we have our commas. So the dots are like the commas in our numbers. So 1 million, right? We have 0, 0, 0. Okay, I gotta stop saying right. So if I have this as my ones, it'll be 0, 0, 0, 0, 1,000. That's where the comma comes in. And then 0, 0, 1 million. $1 million. I don't know if you know Dr. Evil, but that's what he would say. This is a million. So depending on where your ones is. So you could call this as ones. You could, when I'm at the 13 column one, I would usually start in the middle. And then when I start in the middle, I would have dots are the ones. Yes, exactly. So it's so when we count it, it's ones, thousands, millions, billions, and then trillions. Yeah, I love the reference. Okay, Austin Powers. Yeah, right. So I do a lot of quirky things. Oh yeah, like waxing on and waxing off. If you know about old Karate Kid. Yeah. So that's what we do when we want to read the abacus. When we read the abacus, it's about place values. So abacus is a lot about place values. I like to use the colorful one because it's just colorful. It's just easier to demonstrate. Because when I do, however, if you have it, I think having colors might be overstimulating. Then I would probably use the brown one. Okay, I'm gonna head to work. Thank you so much. Yeah, thank you so much, Kai, for the questions. And catch me on my next live. We're gonna be talking about. I talk about abacus all the time, and you can do adding, subtraction, multiplication, and division, and the decimals. So if you're interested, I have that out. Oh, thank you for the follow. Thank you for the like. Hey, Leslie, welcome. I haven't seen you in a little bit. It's been a bit. Okay. So we're okay. So I was doing simple to use, easy to understand. Sorry, new work got me tired. No problem. We are doing midnight math. I was actually on earlier today, and yeah, it was crazy. It was kind of crazy. But yeah, no, new work is tough. Sorry, division, multiplication on it. Yeah, I'm understanding right. Most place is ones and the fives and ones in that, but that's wild. Yeah. I mean, I don't jump right into multiplication. We talk about adding and subtracting first. And then after that, when we all get comfortable, then we start going into multiplication. But it also depends on the group. It depends on the group and how quickly we can go into division. I've never learned that. I have no idea, to be honest. Yeah. You know what? I actually know people that don't know how to pronounce the word abacus. So you have a step up. All right. Are we ready for some new math? We're going to do some multiplication. I was like, thank you. Good to see you. Oh, yeah. Once again. Hello. I'd love that. Okay. So let's talk about some new math. Let's talk about old math. Well, okay. That's the strange thing. Now I don't know which is new math. I don't know what you call abacus, because abacus is not really new math, but new math is following abacus, which is kind of interesting. Okay, I made my calculations in math fast. Yes, I will try a multiplication. Okay, so this is kind of funny. Like, it's so funny. Like, it's so funny. You don't understand. You already know how to do it. It's so funny. Jay, you know how to do it. I know you know how to do it. You can't fool me. I know. So what are we going to do? We got to figure out is our place value, right? We understand our place value. So we're going to do, they call it new math. And I was like, what? That's old math because abacus is old. Right? I'm telling you, new math is old, but it's abacus. So they called it new math. The reason why is when they started doing it, we need to figure out on the abacus, we need to figure out where we're going to put our answer. So that's the one thing that I think would be a hang up, right? One of the hang-ups is, well, why do we have to figure out where we're going to go? Oh, okay. Well, okay. So we're going to know where we're going to put our number, right? We're going to know where we're going to put our answer. So we're going to count our digits, 1, 2, 3. You know, in Abacus, we actually have a conversation with our numbers. I know we don't do that in mainstream math, but we should have a conversation with our numbers because we want them to feel nice, right? We want them to be all nice and fuzzy, and we want to be not so apprehensive, right? So have a conversation with them, give them a little bit of love, and it'll be fine. Yes, we're going to count the digits. So number 1 is starting point, right? Number 1 is starting point. Starting point. That's number 1. So what we're going to do is we're going to count our digits. 1, 2, 3. Because here's the thing, we find our starting point. Because it's multiplication, we're going to add the digits. If it's division, we're going to subtract the digits. Right? So it's the same thing. When we add, it's multiply. When we divide, it's subtract. So they kind of go hand in hand. So that's how they kind of mirrors each other. Okay. So we're going to do 1, 2, 3. So I'm at the 3 because I have 2 digits here and 1 digit here. I'm adding it all together. Oh, thank you so much for the hearts. Thank you so much for the hearts. Okay. So then what are we going to do? Then New Math decides to break up this 97. And I'm like, okay, now what? So in Abacus, we do that already. We take the 4 and we times it by 9. But notice, we're not writing it out. We're using the abacus to help us do the place value. So in Abacus, we don't say 4 times 90, where in New Math it does because you're writing it out. Because you're writing it out, it gets a little confusing. But what we're going to do is we're going to do 4 times 9. 4 times 9 is 36. So if you notice, I will add the 3 and I add the 6. It already shows me I have 360. I don't know if Jose the Panda is still here. But do you see the difference? So having this 0 complicates it. It just makes it a little bit get big. What Abacus does is that Abacus makes it into manageable chunks. We know what 4 times 9 is. 4 times 9 is 36. Nowhere in our multiplication table do we say 90 times 4. So we multiply it out. So step 2 is multiply it out. We multiply outside. Multiply outside. What does that mean? We're going to take the 4 and the 9. It's a 97, so we go the outside first. Does that make sense, Jay? So what we're going to do is we're going to multiply out first. So what we did is we did 36. The reason why we say 36 is because that's how we talk. We don't say 630, we say 36. So that's why it's easier to know what we're doing. Now, what is next? The next one is 7 times 4. We do the inside. We're done with the 9. We got to do the 7. So 7 times 4 is 28. All I have to do is add 20 in my tens column, and I add 8 in my ones column. And that's it. Then we're done. We're done. So my answer is 388. But in New Math, what they do, because we're writing it out, they have to add it all together. So this is what they're doing. We just did 360 on the abacus, and then we added 28. That's what New Math is. That is what New Math is. It's so simple. It's so simple. I cannot believe they call it New Math. What is the count of the blue one? The count of the blue one, hey Chris, the count of the blue one is 5. Okay, so we read the numbers from left to right, so we start with the first number and use distributive property. That's exactly what it is. So you just walked in, how do I use it? So what we're going to do is we're going to count. We're going to count on the abacus. XT, Xins, I don't even know how to pronounce your name. I'm going to show you how to read. So we're going to read the abacus. We do 1, 2, 3, 4. Oh, here's another thing. If you're ever left-handed, you still don't want to do calculations with the left hand. You can still write with the left hand, but the idea is to use the calculations with your right hand. So I was just getting a little lazy. Okay, so how do I know that this is 4? The 4 means that it's being touching the horizontal bar. The horizontal bar tells me that these beads are counted. So if you notice, this column has 4. This is 4, but none of these beads are touching. So those are not counted. Those are all 0. Because those are all 0, then we're done, right? We know how to count. But now what we're going to do is we're going to count to 5. Well, what's 5? 5 is the top bead. That top bead is always going to be 5 no matter what. Is outermost the left? I heard you asking it, but I was typing. Yes, the outermost is the left. So when we multiply, we want to multiply the outermost. Yeah. The outermost of the left multiplication fact, if that makes sense. Always out, then in. Yes. Yes. Well, the problem is here. Okay, sorry. We do. Okay. Well, okay. That, you know what? It's different. It's okay. Let's take a step back. When we have more numbers, let's say 97 times that by 42. It's the left columns, it's the left ones first. So 4 times 9 and then 4 times 7. When that's done, then we do 2. Then we do 2 times 9 and then 2 times 7. How do we do that? So what exactly? So if there was 97 times 40, would it start with a 9 and a 4? Yes, exactly. Hannah, exactly. If you multiply the way you read for the first set, you will start from the left to right. Exactly. Oh, word perfect. Yeah. Right? So Hannah said 97 times that by 40. Same thing. So it's 4 times 9, 4 times 7, but it's left and then the right. So then we do 0 times 9 and 0 times 7. So it's still the left, but So it's still the left, but it's not outside. It's not 9 times 0. So it's not the outside, it's lefts. So even if we do more, let's do 5 digits. 1, 2, 3, 4, 7 times that by 4, 7, 8, 9. It's still the same thing. It's still 4 times 5, 4 times 2, 4 times 3, 4 times 4, 4 times 7. Then when that's done, you restart, and then it's 7 times 5, right? 7 times 2, 7 times 3, 7 times 4, 7 times 7. When that's done, it'll be 8. 8 times 5, 8 times 2, 8 times 3, 8 times 4, 8 times 7. When that's done, we do the final one, which is the 9. And the 9 will be this green. 9 times 5, 9 times 2, 9 times 3, 9 times 4, 9 times 7. So, right, I understand. Start at the leftmost, you read and distribute each. Yes, yes. So, back to this. We're going to learn how to read. Thank you, Leslie. 1, 2, 3, 4. If you notice, all these beads are touching the horizontal bar. The horizontal bar tells us that this is being counted. So when it's being counted, we know that we have 4, but 5 is going to be a problem. But 5 is not a problem because 5 is always going to be the top bead no matter what. So we have the top bead is 5. So if this is 5, 5, 5, 5, 5. So because these are all 5s, this is what's being counted. They're touching. These are all 5s. However, when we do 6, that's what 6 looks like. It's a 5 and 1 is 6. 5 and 2, 5 and 2 is 7. We can even count it. 5, 6, 7. And then there's 8. 5, 6, 7, 8. And then there's 9. 5, 6, 7, 8, 9. Afterwards, what about 10? Well, 10 is the next column over, just like how we write. We write 1 and 0. So we count it 1, 1. This is 11. This is 12, 13, 14. And we just move the beads so we can count. Oh, so what's 25? Well, let's see. 25 is a 2, so I'm going to put 2 here, and I'm going to put 5. That's what 25 is. Thank you so much for the question. And so when we count, let's continue to count. Well, what is 75? 75, I just add the 5. So this is 50, right? 75. We have our tens, we have our, we have our ones, we have our tens, we have our hundreds. So then, what's the other question? Well, what's 475? So this is 475. And then we have 5,475. Then what's after the decimal? What's after the ones? The ones is the decimal. So we can have 35 cents. Why did I start in the middle? I started in the middle because I have this indicator. This indicator tells me that this is my ones place. So in my ones place, I know that I'm going to start here. You can start in any ones place. So how do you use the regular bead table then? It doesn't have any bars on it. I'm not sure what you mean by the bead table. The regular bead table. 55, so 55 will be 5, 5. Yes, exactly. 55 will be here. The 5 in the ones and the 5 in the tens. Because we have the ones, the tens, the hundreds, and the thousands. So then we have 55.55. So we, not paying tax person. So 55, exactly. Cgen would be all this down like that, exactly. The thingy you use right now, sorry, the name of it. This is called an abacus. Oh, I see. So this is what we call an abacus. So do you use a regular bead table then? It doesn't have any bars. So when it doesn't have any beads touching the horizontal bar, this is considered 0. So what is 60? 60 is 0, 6. 60, because we have a 6 and we have a 0. Thank you so much for the questions. I really do appreciate all the numbers. Let me know more numbers. Let's find some more numbers. What's another number? The old type they used back in the day. Was a Chinese abacus. So the Chinese abacus is kind of similar. So Shane says 9. Oh, come on, Shane. 9999. That's it. This is super interesting. 6 in the tens place. Yes, that's correct, Jay. 6 in the tens place, 460. Come on, Shane. Are we doing multiplication already, Ethan? Could they mean the big one like the 10 row and not the horizontal? Yes, I believe you're right, Hannah. So yes, the ones with the ones that doesn't have the horizontal bar, that is a 10 bead, and that's different. But it's still an abacus. Yes, I think you're right. But I don't have an example of that. I only have an example of this one, and I only have an example of the Chinese abacus. Maybe she's talking about my target tool. Yes, but your target one has 11 beads, and that's what's confusing. It blows my mind that they decided to use 11. Oh, so I was doing research. Somebody was asking if this was a base 10. I'm sorry, if this is a base 5, this is not a base 5. This is still a base 10 because we can still count to 10. Base 5 just means we're only using from the digits of 0 to 5. That's what a base 5 is. Okay, curious. So when I add 25 plus 25, I add 25. I have 25 and I want to add another 20 and I want to add another 5. This is, Sejun, just to let you know, this is where we have to start learning how to do formulas. Well, one of the formula is to understand how to make a 5. To make a 5 is to be able to, and then this is going to be, I missed that. Oh, yeah, yeah. Yeah, no, this was, I don't, it was earlier today and somebody was asking, and it was after you came in. And they were talking about the base 5, and I was like, I don't know, maybe. Sorry, so I'm back to here. So, Sejun, it's going to be a little bit complicated because now we're doing multiple stuff. Yes, thank you, Leslie. It is going to be plus the 10. So when I want to add the 5, because I want to add 25 plus 25, I already added my 2. I already added this 2. So I got 25. So I need to add this 5 here. The problem with this is I don't have enough beads to add another 5. So to add another 5, I'm going to plus the 5 is equal to plus the 10 minus the 5. This is a formula that we need to memorize. So with this formula, it tells me minus or plus the 10 minus the 5. Leslie, do you see that this is now a two-step equation? What is the two-step equation? Well, we have this. We don't have enough beads to add the 1. When we don't have enough beads to add the 1, what do? Do we remember? Who the heck am I? Oh, wow. So what we're going to do is we're going to plus the 1 is equal to plus the 5 minus the 4. So we need to plus the 5. Yes, we got to bring down the 5 and the 10s. Exactly. We got to take away the 4. That's what this is, right? And then we have to minus the 5. So then my answer is 50. So the questions, Sejun, the questions, yes, exactly. The two-step equation, we can use the prime factor process, only the formulas are subbed in. Yes. I was doing research on the prime factoring as well, and I'm still trying to wrap my head around it. I got to think about this one. Yeah, the problem with this one is that it deals with more than what we talked about. So what I would probably say is let's do, you know what? Let's do something. See, that's the thing. Doubles is not easy because it depends on what the numbers are. What we could do is 25 plus 23. Let's do that. We can do that. That's easy. Because what do? We do 25 and then we add 20 and then we're going to add the 3. So we add the 3. So my answer is 48. So you could do that because there's no formulas involved. It gets a little hairy when formulas are involved. Yeah. Make sense? I don't know if anybody can hear my dog. Thank you. Yeah, no problem. Let me know if there's another question. But you have to be careful with the questions because not in mainstream math, we just give a bunch of questions to kids and we just expect them to know it. And then we want them to like make tens and stuff. But in Abacus, there's a formula. There's a set. Can you do? I want to see that one. That one's a little bit more hairy as well. The reason why is because now we're going to do two-step. The question is 99 plus 1. So again, we have 99 and we need to add the 1. Well, the problem is there's not enough beads to add the 1, right? So what are we going to do? To add the 1, it's equal to plus the 10 minus the 9. That's what we have to do. But notice, I cannot plus the 10 here. So if I cannot plus the 10, this is again another two-step equation. What does that mean? So what does that mean? Right here, I cannot plus the 10. Right here, I can't plus the 10. So what do? I know to do it again. Plus the 1 is equal to plus the 10 minus the 9. So let me put it all together. I'm going to put it all together. The formulas can only use 5 or 10. Correct. But it's also depending on the number. The first thing you need to ask is, can you use a 5? Leslie, almost. So when I rewrite this, I'm going to combine it together. So what I'm going to say is plus the 10 minus 9 minus 9. So if I line it up, I have the 10 minus the 9 minus the 9. Does that make sense? So what I did was I took this formula and I added my 9. I added my 10. So when I bring it down, I line up my formulas. So that's why I always say it out loud so I know what I'm doing. So plus the 10 minus the 9 minus the 9. And then my answer is 100. So we could do 100 minus 99. So 100, we have 100 minus 9 minus 9. Okay, wait, hold on. How do you know when to use the formula? How do I know? The question to ask is there enough and how do I do it? Correction. Formulas can only be used one. Yes, correct. So 1 has 2. So 1 has 2 formulas. So 1, 2, 3, and 4 all have 2 formulas. So, Chris, to ask how we do it is whether or not we have it. So the question is 99. So we do 100 minus 99. So again, we go left to right, and I want to take away the 9. To take away the 9, I have to minus the 10. So I'm going to take away the 9 here. I minus the 10 plus the 1, right? So I minus the 10 and I plus the 1. That's the formula. Plus 9 is equal, minus 9, I'm sorry. Minus 9 is equal to minus the 10 plus the 1. That's the formula. Are we starting with 100? Yes, we're starting with 100, and we're going to take away 99. So I'm going to take away 9 again. I don't have enough beats to take away 9. My formula is minus the 10 plus the 1. So I minus the 10 and I plus the 1. So then my answer is 1. Yeah, yeah. It's nice because it works well. And then because we know how to plus, we can minus. Yeah. So let's do it again. So I have 100. I have 100. Let me do that. I have 100. 100. I'm going to take away 99. Take away 90. Take away 9. Take away 90. Take away 9. Take away 9 is minus the 10 plus the 1. So I'm going to minus the 10. All I got to do is go to the 1 column over. This is where we are regrouping. Old math, they call it borrowing. In Abacus, we just call it minus 10. So we're going to minus the 10, and then we're going to add the 1. That's it. So we're done with this one. We're done with that one. But I don't want to write out the answer yet because I'm not done. The next one is minus the 9. When I minus the 9, again, I minus the 10 plus the 1. So I'm going to minus the 10, I'm going to plus the 1. So I minus the 10 and I plus the 1. Now I can write my answer because I'm done with this. I'm done with that. Hey, delete. Yeah. So, yeah. You should go outside, check out the eclipse. Oh, yeah. I'm laughing out loud because my brain is functioning. Not gonna lie, this is more interesting than all the other math classes I ever been to. I I don't know if the I'd have to like pause my live. I'd have to leave. Or I'd have to pause my live to see if there's anything. Wait, is this an abacus? It is an abacus, Moon. Moon socks. Yes, this is an abacus. So we're reading the abacus. It's because she's been teaching for a while. Oh, yeah, for sure. I've been teaching for about 20 plus years now. So an abacus is a little backwards. How are we taught doing it on paper? I'm sorry. With the abacus, it's a little backwards. How we're taught to do it on paper? Okay, that's a silly question. Wait, no, it's not a silly question. No, this is an abacus. So we have 1, 2, 3, 4. Not a tax-paying person. So with abacus, it's a little backwards. With abacus, it's new math. Sorry. They said it's left to right, not right to left. Yeah. Yeah. So it's interesting because in school, when we do adding, we do the ones, we do the hundreds, do the ones, the tens, then the hundreds. In abacus, we go hundreds first because when we talk, we say 100. We say 348. We don't say 840, 300. Yeah. So it in abacus we talk forwards, but in mainstream math we add backwards. I see what you're saying. Yeah. So interesting. Oh, and that's the interesting. So in new math, they're starting to calculate forwards, which is interesting, which is really interesting. And they're starting to call it new math. And people are like, this is crazy. Why are we doing it this way? It's not crazy, actually. It makes more sense. But the difference is on the abacus, we do it and it works. Whereas when you write it out, you need to write out the extra stuff, and it's just more. It's just overwhelming. It's just more complicated. Whereas if we do it on the abacus, it's just already there. So here, the question is where are we going to start? Why are we going to start over here? Because I want to count the digits. Now we're doing multiplication on the abacus. So on the multiplication, I want to know where I'm going to start. To know where I start is I'm going to be here. How do I know? Because I'm going to count my digits. We're having a conversation with our math. So we're going to count the digits. 1, 2, 3. 1, 2, 3. So this is where I'm going to start putting my answer. As I put my answer, I'm going to multiply it out. So this is where I go from left to right. So I multiply 4 times 9. 4 times 9 is 36. Now, in abacus, we just say 36. 6. We just add it, right? We just multiply it out. But if you notice, abacus already keeps my numbers. So I already know it's 360. I don't have to write 90 plus times 4. I don't need to do that because it already does it for me. When we write it out, it makes sense to write it out. But if we actually utilize the abacus for what it is, then we don't need to. We don't need to worry about putting the 0. So that's why I X'd it out, because in abacus, we just say 9 times 4, and it's 36. So in the abacus, we say 360, but we just move the beads. So as we move the beads, my next number is 4 times 7. 4 times 7 is 28. All I got to do is add 20, and I add the 8. And my answer is 388. So I did it on the abacus to help me add. I did it on the abacus to help me move things. When we write it out, it gets more complicated. And that's what they did. They wrote it out. Easy. But on the abacus, we calculate it on the abacus. Thank you for the like. Thank you. Thank you. So wait, is the eclipse still going, or is it already done? When did you learn to use the abacus? I learned the abacus when I was probably early 30s. I know I learned it before my child, but my kids know. I have 3 boys and they all know how to do the abacus. Uh, do I like it? I didn't in the beginning because I didn't understand why, but now I understand why. And now when I do comparison between mainstream math and abacus, a lot of the new stuff that's happening is very similar to what abacus is. And it's very interesting to see how it comes back again. Very cyclical. So in old math, what we did is we would times the ones first, so it'd be 7 times 4 and then 7 times 9. But in new math, they're going to go outside. So they start with the tens first and then they start with the and then they do the ones, which is very interesting. But in abacus, we've always done it from the outside in. We've always done it from the tens to the thing. So that was a very long-winded answer to say that I've taught abacus for more than 20 years. I never learned abacus when I was a child. My kids hated it because when does a child like learning math? But I truly believe it is very helpful. It has helped them a lot. Yeah. I believe the totality of the eclipse ends around 3:30 a.m. Eastern Standard Time. Oh, okay. So I still okay, cuz I'm in the West Coast right now. I like learning math. Ah, Leslie. Thank you. But yeah. Okay. But yeah, that was the interesting thing. So this is what they call new math, and I'm like, this is crazy. This is what abacus is. So I'm trying to figure out how to create a video to explain what new math. But the problem is I have to show how to read the abacus before I could show how to do it on the how to do that. And I think that's what it is. By the time I was 7, I taught myself pre-algebra. Hey, that's fantastic. That's very impressive. I don't think I did any of that. That's very impressive. I'm honored that you still enjoy my classes since you know math so well. I am honored. I appreciate that. So yeah, it's just to tell the world what abacus is about because I don't think I mean there's a bunch of videos out there, but I think I'm not sure why it hasn't caught on in the United States. I had a toy computer. It had very educational games, so I didn't know I was learning. I was simply playing games. Yeah, I could see that. You know what? I could see that, and I think that's why I think that's why I was trying to make my worksheets interactive when they do math. So this one is the plus tens, and I was trying to be more interactive. So, all right, but yeah. Anybody else have questions? Seems to be coming down a little bit. There's still 19 people in the room. uh, all right. What else? So that's about reading the abacus, and it's just interesting. It's just interesting on how everything is just coming full circle, especially with the whole new math stuff. I'm going to try to figure out more correlations about how to bring in new math and the abacus, but it's very interesting on how everything is. So I'll be back again another day. I'm gonna go get some sleep. I've been going to sleep like at 3 a.m. Waking up at 7. Yeah. Head to bed. I'm gonna end my live. I'm going to head to bed and I'm gonna look at the eclipse. So have a good night, everybody. Thank you again. And I gotta marinate on like this whole new math thing. But I do appreciate everybody joining. Bye, Ethan. Good night. It was good talking with you too, and I'll see you in my next live. Yes, you too, Melinda. Sleep well. Thank you so much, everybody, for joining me for my epiphany that new math is actually abacus. All right. Have a good night, everybody, and go take a look at the new moon, the eclipse. Bye.